Okay, this is just a little quick lesson on gears, which is new on the specification. So another way of transmitting forces is by gear. So you can see what we've got here is a big gear wheel. The big gear wheel's got 40 teeth on it, and a small gear wheel with 16 teeth. Right, this ratio of the number of teeth has to be the same as the distance around the edge of the gear, because if the teeth aren't the same size, they won't mesh together. So if you do the maths here, you can see that 2 pi times 0.25 will be 2.5 times as much as 2 pi times 0.1, and therefore you've got 2.5 times as many teeth. Okay, so what happens when they rotate is that this gear will go round 2.5 times for every time this gear goes round once, because 40 teeth have got to go past this point, while these 40 teeth go past here. So the only way 40 teeth can go past is if it goes round 16, 32, 40. That's 2.5 times. So the big gear goes much slower than the small gear. If we think about the energy used when we move a gear, you'll see that these two gears go round, and just like with levers, we're not gaining any energy, right? Because a force moving round here will move a bigger distance than a force moving round here. So gears are not a way of increasing the energy in a system, okay? They're just a way of increasing the rate of rotation. So if we apply that to some systems, usually the gear is attached. So if you imagine, like on a bicycle for example, the gear wheel on the back is attached to the rear wheel going round. We can apply this to lifting things. So if I rotate this gear, right, as this gear goes round once, this gear with fewer teeth on it will go round 1.5 times. So as this 60 Newton force goes down 1.5 meters, if this gear is attached to this big wheel, this will go up 50% extra, 2.25 meters. But in terms of the energy we use, it's the same, as I'll show you in a minute. If I do this gear around here where we've got a small wheel attached to it, right, the small gear goes around more times than the big gear. So in this case, as this 60 Newton force goes down 1.5 meters again, it can lift this bigger force up by 1 meter. But if you do that, so what can happen is a small gear can be used to move a force more quickly, or a large gear can use a bigger force more slowly. But if you look at the energy, we've got 60 newtons times 1.5 meters, 90 joules we've put in. We've got 40 joules times 2.25 meters, 90 joules out. Okay, with this system, again, I've put 90 joules in, 60 times 1.5, and my 90 newtons has moved 1 meter, so I get 90 joules out. Okay, so we can change the size of the force we get out, but we can change the speed that it moves at, but we can't change the energy. Okay, just a couple of more examples for you to have a look through here. So this gear has got 10 teeth, this gear's got 20 teeth. So if the gear rotates, this gear rotates 10 times, then this gear will only go around 5 times. If it's 2 meters around this wheel here, where the distance I've moved is 5 newtons times 2 meters is 10 joules, but I've done that 10 times, so I've done 100 joules of work in. If I put 100 joules of work in, I'll get 100 joules of work out, as long as there's no friction in the system, which means that this force here, which has also moved the same distance, so this distance has also moved 10 meters around here, but that means it can lift a 10 Newton force. You'll notice the ratio of the forces, 5 to 10, is the same as the ratio of the number of teeth. Okay, on this one, the one on the left has got 24 teeth, the one on the right has only got 8 teeth. So if this one rotates 10 times, this one's going to have to rotate 30 times to get the same number of teeth go past. So 10 times is 240 teeth, which is 30 times 8. 30 Newton force, if this wheel is 2 meters round, a 30 Newton force times 2 meters is 60 joules, times 10 times round is 600 joules. Put 600 joules in, I'll get 600 joules out. That means the rim of this gear will move the same distance, so this will also move 60 meters, but this means I can only lift a 10 Newton force. Okay, so in this case I can lift a bigger force a smaller distance. In this case I can lift a smaller force a bigger distance. In terms of applications for this, for example, bike riding is an application. What you want when you're riding a bike is that your legs go around the same number of times. It doesn't matter if you're going along the flat or up a hill. A bike is designed so you pedal at a certain rate, but the wheel goes round at different rates according to what you're doing. Okay, so you get the same, what they call the cadence, the number of times per minute that the cyclist pedals. If you're going up a hill, you want a big gear so that you can get a big force moving fairly slowly. But if you're going along the flat, trying to go fast or sprinting, what you want is a small gear, providing a smaller force but moving very quickly.